I'm continuing with section 7.3, and at this point in time we're discussing a different type of composite variable or value. It's probably better to say value than variable. What we're looking at this time, we already saw an array, and the thing about an array is it will allow you to keep a reference to this entire block. Maybe you wanted to call it A, and you could access some arbitrary number of items just by adding an offset to A. So A0 might be the first item. It's at offset 0 from the beginning of the array. That's why we use a 0 instead of a 1, which means A1, you've skipped over 1 and you're now at the second position, and A2, you've skipped over 2, so now you're at the third position in the array. The index kind of tells you how much you have skipped over to get to your current spot in the array. So we've seen that. So if we wanted to have n elements, an array is a good solution. The constraint that we saw on an array is every item in your array should be the same size. If we imagine that somehow everything that we're storing in the array, let's imagine we're storing strings like people's names. So let's imagine a name is actually up to, let's say, 15 characters. I'm just going to say cars instead of characters. I hope you can understand. So that would be a person's name. And we'll do it like this. So you can imagine a name is actually an array itself. And you have indexes 0, 1, 2, up to 14. Because that would be 15 different values. Each position in this array occupies 1 byte or 8 bits, because that's the size of the ASCII character code. And in that ASCII character code there is a special symbol to indicate the end of a string. When we're typing out strings, we type in this symbol /n to indicate a new line. I'm sorry, that's not what I wanted to do. We type in a 0. So 0x00, or we could just type in /0 in a string. These are all different ways of saying end. It's the end of a string. In hexadecimal, it's a 0. New line is something different. I didn't mean to put that there. That's a symbol that means whatever you're writing, go back to the next line and continue writing it. It doesn't actually end the string. So we can represent a string then by putting the characters in here, and wherever the string is supposed to end, we store a 0. So for instance, my name could be represented as a string using the ASCII characters for J, O, H, N, followed by a hexadecimal 0. So I'll just write a /0 for that. And we can store strings up to 15 characters. We just can leave the rest of this. We don't care what it is. We can set all the rest of those characters to 0 if we want. And this way we could store a list of people's names, but every single name occupies 15 bytes of space. So if I wanted to have an array of the names of people, then I would set it up like this. I would have, just a second, I need to make sure I can see what I'm doing. I would set up an array with, imagine that I wanted to have up to 20 people. And I'm just going to use evil ellipses so you can kind of fill in the difference. And each position in the array is going to be a 15 character string. So the first string might be J, O, H, N, and a bunch I would have to pad it with a bunch of zeros, a bunch of end of string characters, all the way to the end. The second string might be B, O, B, and then the end of string character all the way to the end. And you can just continue like that. My son's name is Jonah. He's sitting here with me. You want to say hi, Jonah?
Hi.
I misspelled my own son's name, but I fixed it. Ends with a /0 to indicate the end of the string, and /0s all the way to the end. So the thing here about this array, it has, well, actually it has 21 elements, because zeros in there as well. So 21 would be in no man's land at the end. So you can skip over 20, and then you're at 21, right? So this would be the 21st character because you had to skip over 20 to get to it. I almost wonder whether we shouldn't write arrays indexes like this. You know, this is 0, this is 1, but whatever. So the important thing to notice here is that in order to represent an array of 21 names, it's important that every single one of them is 15 bytes. Right? Because in order to get to, let's say, the 18th name in the list, which is Noah, and he's padded with zeros at the end. In order to get to that 18th position in the list, I take the memory address of the beginning. Let me just pick some random hexadecimal address, 0A00. Right? Let's imagine this is the memory address of the beginning of my array. Since each position is 15 bytes, I need to add 15 to this, which means the next position is going to be at 0x0AOF, if you can do that math in hexadecimal, right? And continuing down, this is going to be, let me just write out what that is. It's A00 plus, and I'm going to put 15 decimal. The convention here is I put 0x to indicate that's a hexadecimal number, and I just added a decimal number to it. You would have to convert that to hex before adding it. So I would move 15 down to get to the first position. In order to get to the 18th position or any other index, I need to add 15 times I. So in order to get to position 18, I would need to multiply 15 times 18, which is I just did that completely wrong. So 15, my son's going to be embarrassed at me. I can't do normal multiplication. So 8 times 15 is 40. And then we are looking at 184 bytes down to get here. Right? So in order to get from the beginning of the array to position 18, you're looking at 0A00 plus 184 decimal, which is so we have 11 remainder 8, so this is B8 that we're adding. So the address of this guy is going to be 0AB8 in hexadecimal. Right? So just to be clear what's happening, we have an array. Every item stored in the array must be the same size. So if we want to store people's names, we always need to represent them as strings with 15 characters. A string itself is an array of bytes, right? So every name is an array of 15 bytes, which we show here, and you can access position 0 through 14 of that string. We set the individual characters to form a name, and we end it with the zeros to indicate that that string is done, and don't print it. Right? In order to have an array, it's important that every position is the same size, because in order to jump to a specific position in the array, we have to add some multiple of the size. So 15 is the size of every element, and we want to access index I, we have to take the position of the beginning of the array, and we add 15 times the index. Right? So in order to access things in an array, we're doing math. Okay. Fortunately, your computer does this for you and won't mess up as much as I do in calculating those offsets, but it is kind of important to understand that's what's happening in an array. There is another data structure which I wanted to talk about now. And actually, I didn't intend for this to be a second lecture on arrays, but it is. So I'm going to kind of wrap this up, and I will call this video Arrays Part 2. And then I will pick up again talking about records, which is a different type of composite data structure.